by way of introduction, I want to point out simply that agriculture is responsible for about 7% of the U.S. Greenhouse gas emissions, which is significant, but it's not a substantial amount. And while we want to reduce the footprint of agriculture, it's certainly one opportunity for mitigation. There is in fact a greater opportunity in agriculture's participating in mitigation markets by providing opportunities for carbon credits and greenhouse gas credits in particular. And I want to point out by way of introduction the global carbon budget, the global CO2 budget, and just to illustrate where some of those opportunities are. When we talk about the global CO2 budget and we talk about reducing the budget, we can think about the total sources, which are primarily emissions from fossil fuels and emissions from deforestation, and the total sinks, atmospheric loading, uptake by oceans, and uptake by the terrestrial biosphere. And when we talk about stabilizing the atmospheric CO2, what we're really talking about is reducing this loading source to zero. And in that way, it's not quite as simple as that, but ultimately we want to bring the annual load of the atmosphere of CO2 to close to nil. And agriculture can participate in that activity in two major ways. One of them is by offsetting fossil fuel CO2 with biofuels, as we heard about this morning. Another one is to increase the uptake of carbon by the terrestrial biosphere, and in particular by soil carbon sequestration. And in both of those cases, agriculture can play a much greater role than one might expect based on simply the total amount of greenhouse gas emissions that agriculture is making to the loading. Yes.
Just you said 7%, and I've listened to the series of symposiums leading up to this event, and you often say more like 30 to 40. I'm curious what goes into your 7%.
So the 7% is the EPA's estimate in the National Greenhouse Gas Inventory of the total greenhouse gases emitted by the U.S. And 7% includes that in which agriculture is directly involved, not the entire industry.
Crops and livestock.
Crops and livestock, that's right. So carbon sequestration is largely the potential for soil carbon sequestration is largely based on the fact that agricultural systems have lost carbon historically on conversion from their native systems. Locally, about 40% to 60% of the original carbon in soils is lost within 40 to 60 years of initial clearing. This has been known for a number of decades. And it's possible to calculate that globally some 54 petagrams of carbon have been lost since the mid-1800s. And with the implementation of certain carbon conserving practices, in particular increasing carbon inputs to soil in the form of crop residues and cover crops, and by slowing decomposition with the implementation of technologies such as no-till, it's possible to recover somewhere on the order of 0.3 to 0.5 petagrams of carbon per year globally. And comparing this to 4.1 petagrams of carbon of atmospheric loading, you can get a flavor for the global potential for agricultural carbon sequestration being a significant piece of the mitigation portfolio. Now, another piece that is less often considered, but one that is potentially as or even more important than carbon sequestration, and that's mitigation of the other greenhouse gases than CO2 in agriculture. And it's important to understand that other major greenhouse gases, biogenic gases, methane, and nitrous oxide in particular, are also rising exponentially since the 1700s. And both of them are quite important in agriculture. Agriculture is a major source for both of these gases. And they're particularly important from a mitigation standpoint because they have a much stronger impact in the atmosphere on a molecule-by-molecule basis than does CO2. nitrous oxide in particular is about 300 times more important as a heat absorber than is CO2. And importantly, most of the human sources of nitrous oxide are from agriculture. It's hard to see with the contrast on this slide, but about 80% of the human sources of nitrous oxide are agriculturally derived, with about half of those emissions coming from agricultural soils, which provides an opportunity for mitigating that nitrous oxide production and thereby playing a role globally in greenhouse gas mitigation in general. When one tallies up, when one puts this total on a CO2 equivalent basis, that is, multiplies the amount of N2O coming off times the 296 global warming potential, one can calculate that there's a total annual impact of about 1.2 petagrams of carbon equivalent, which again, when one compares it to the 4.1 petagrams of carbon of atmospheric loading, you can immediately see that there is a very strong potential for nitrous oxides playing a mitigation role here. We're going to see some of this today. We're going to have a series of talks which illustrate some of the research that's going on at the Kellogg Biological Station in the area of greenhouse gas mitigation and biofuels impacts. We'll first hear from Terenzio Zanoni. We'll have a series of 10 or 12-minute talks. We'll first hear from Terenzio Zanoni. We'll talk about CO2 fluxes from agricultural crops in the U.S. Midwest on conversion, in this case on conversion from CRP land, Conservation Reserve land, which is a concern as we move into an era where CRP land may be converted to biofuel crops. In particular, we need to know the total impact of that conversion. Ajay Bardwal will talk about water footprints in biofuel cropping systems and some of the impacts unrelated to carbon per se, but also an important environmental concern as we move into perhaps more biofuel production in these landscapes. Ilya Gelfand will talk about the energy efficiency of different types of cropping systems under food and fuel scenarios to give us a flavor of the ultimate efficiency of these systems and relative efficiencies. Julie Dahl will talk about some of the socioeconomic challenges implementing mitigation practices, particularly from a farmer's perspective. And then Neville Miller will round up the afternoon with talking about offset opportunities for row crop agriculture, specifically looking at some of the N2O, some of the nitrous oxide opportunities. So we'll have time for a few questions as we move through the afternoon, and if we have a few minutes at the end, we'll also be able to open up for comments and other discussion.